Come back to starting diagram dealing with lamprey, shark, salmon and lizard. And now the characters 1, 2, 3, 4, 13 and 14 will be brought into the picture once again. These characters have been defined in terms of consistent, congruent and conflicting. A lamprey can breed in fresh water, so also the salmon. They have a common feature, character 14 is called conflicting. With respect to character 1, character 2 supports the same grouping, that shark, salmon and lizard have got jaws, whereas lamprey does not have got jaw, and paired fins are present in shark, salmon and lizard, whereas in lamprey paired fin do not exist. Therefore, jaws, this character is called as a congruent character. Just recollect the definition of consistent or logically consistent. Since no taxa is present in the two groups, characters 1 and 2 are said to be consistent. Let us look at some other terms, very important. The monophyletic group, they contain most recent common ancestor plus all and only all its descendants. For example, in this diagram, ancestor X, which can be hypothetical or real, that means either I may get a fossil of X or I do not have any fossil, but I have hypothesized that there was a common ancestor, and C plus B together will define a monophyletic group. Now, there is another way of defining monophyletic group from the same figure, ancestor Y, X and then A, B and C define a monophyletic group. Or there is another way of defining the monophyletic group, ancestor Z and Y and X and A, B, C, D all together can also be called a monophyletic group, because they contain the most common ancestor, which need not be most recent all the time, and all and only all its descendant. What is a paraphyletic group? What remains after one or more than one parts of the monophyletic group is removed. Consider only the shark and salmon, A plus B. Now, they have a common ancestor Y. Now, the ancestor Y has been removed. Only these two are considered. Then we call this A plus B as a paraphyletic group. What is a polyphyletic group? They consist of conflicting characters. For example, or the members not coming from a common ancestor. For example, lamprey and salmon, these two have a common ability to breed in fresh water. Now, if we look at lamprey and salmon, they do not immediately come from a common ancestor, but if we track back in the geological time, yes, they do have a common ancestor, but immediately we do not see that this line and this line are converging. So, these two can be called lamprey and salmon. That means, here B plus D is a polyphyletic group. It is desired that in paleontological studies, monophyletic groups are prepared. Here is a self-explanatory diagram representing the monophyletic group and the paraphyletic group. So, with the definitions we have learnt about the monophyletic group, paraphyletic group and the polyphyletic group. A, B and C together can be called a monophyletic group, because they are coming from a common ancestor, or they can be grouped together. Paraphyletic group, for a large monophyletic group shown in this diagram, a part has been shown, so it can be called as a paraphyletic group. And when we are looking at two small groups I, J, K and L and grouping them together, we can call it polyphyletic group. Three other terms are required to know. The crown group is a monophyletic group containing living species and extinct species. So, this is the timeline. Consider that cladogram consisting of also a timeline here. This is the younging and is the present day. Now, as per the drawing, these are the species which do not exist because they do not touch this dash line. So, the present day existing species marked by these 4 circles and them together consist of the crown group. What is a stem group? Polyphyletic remainder consisting of extinct species. So, here we deal with the extinct species. So, species which do not fall on this present day timeline, such as all these species, can be called as the stem group. What is Plesion? It is a monophyletic group within the stem group. Now, within the stem group, a monophyletic group has been worked out, and that is known as the Plesion. So, we can say that Plesion is a subgroup inside the stem group. The monophyletic group can be presented in terms of such boxes. We can also call them as the Venn diagrams, although they are not exactly the kind of Venn diagrams that we have seen in the set theory. C and D and a smaller rectangle, which means C and D consists of a smaller group. B, C and D inside a bigger rectangle means B, C and D comes in a bigger group within which C and D exist. The paraphyletic group example is B and C, and they are kept inside a rectangle, a Venn diagram presentation, and the nested parenthesis approach I have already described, by which we can write BC as an example of paraphyletic group. Example of monophyletic can be written as CD and then B and then the bracket close. Then comes the polyphyletic group. A and C are defining a homoplasy. How we group the character can be presented in this cladogram. BC character can be identified based on which B and C can be grouped, and if we consider ABC character, that means characters of A, B and C are taken care. An example of this A, B, C can be Archaeopteryx, ostrich and raven. Archaeopteryx got extinct, we do not have any modern analog. Archaeopteryx is found only in terms of fossils. When we say the BC character, there can be an example of the pygostyle for the birds, that means birds with bones in the tail end, and ABC, this one can be existence of the feathers. Now, for the fossils, not all the time whether feathers were present or absent can be cross checked. In the beginning, I referred that a cladogram has no implied time axis, and if this is so, our very first example can also be presented in this way: lamprey D, shark A, salmon B and lizard C. This is the Venn diagram presentation. B and C can be grouped together, B, C, A can be grouped together because they have a common ancestor, and all of them come under the same rectangle, and this is a nested parenthesis approach of presenting. Now, from here we can create several evolutionary trees or simply trees, and that can be constructed with hypothetical ancestors x, y and z. These are the x, y, z. While talking about graph theory, the definition of tree was given. Similar concepts coming here with an additional word, evolutionary tree. Some of these trees may also have real ancestors. The hypothetical ancestors, as I just now pointed out, x, y, z in these diagrams, but there can also be real ancestors. That means out of these species we can also think in terms of the real ancestors. A single tree is same as the cladogram. So, cladogram is one possible type of a tree. Now, here comes the importance of stratigraphic sequence. In fact, from the next slide onward, I am going to present you the importance of stratigraphy in these studies, and that is the reason I am bringing the cladistics discussion in the stratigraphy lecture. We can find out in subsequent slides that some trees containing the real ancestors are less likely to be true. We will see them, how stratigraphy plays importance. And systematists who are studying and grouping these organisms, or grouping the taxa, sometimes turn cladograms into trees to comment on the evolution, and sometimes the Dollo's law is used. The Dollo's law states that once a character is lost, it never comes back. That means, if I write some character 2 and then after some time I write within bracket 2, that means character 2 is lost. After character 2 is lost, again 2 will not come back. So, we can write in a cladogram x and within bracket x, but first writing x, then within bracket x, and then again writing x is not permitted. Now, coming back to this reference, there can be 12 possible trees that can be constructed. Let us see only 5 of them, 1, 2, 3, 4 and 5. B and C constitute a closed group. So, that is done here. X is the hypothetical ancestor, then ABC makes a bigger group, and that is being done with the hypothetical ancestor Y, and then D and ABC all come from the same hypothetical ancestor. So, this is one possible tree. In this case, note the difference. Here, instead of 3 hypothetical ancestors, only 2 hypothetical ancestors have been defined, and this tree also represents the same. In this case, just a single hypothetical ancestor has been defined, and B has been considered as an ancestor of C, and in this case 2 hypothetical ancestors have been used, and D is considered as the ancestor of A, B and C. And this is another situation where we are thinking that from D actually A has come, from A B has come, and from B C has come. Let us discuss how stratigraphy can be useful. Consider 3 species A, B and C and 4 characters 1, 2, 3 and 4. Character 3 is present in species A, character 1 is present in species B and C, character 4 is present in species B. So, the cladogram can look like this, that species B has got characters 1 and 4, species A has got only character 3, and species C has got characters 1 and 2. Now, if we look at the stratigraphy, consider this is the oldest layer and this is the youngest layer. This is the time direction, or this is the younging. A is restricted in the lowermost layer, B is restricted in the intermediate layer, and C species is restricted in the topmost layer. There is no superposition of A and B, B and C, nor is there any superposition between A and C. We can have 2 kinds of trees from this single data matrix. Consider A has got character 3, this one is taken care. Then at some point character 1 is added and 3 is gone. Within bracket, when we are writing 3 means this character is changing from 1 towards 0. That means from derived character to the primitive character, going back to the primitive stage. For which character it is happening? For character 3 it is happening. So, once I am thinking in this place, that means in species B I am getting characters 1 and 4, and we look at this row, character 1 and 4 are present, and here 2 was added. So, in species C we will get character 3 got out. So, 1 and 2 will be there. Look at this row where character 1 and 2 can be found in species C. So, what has happened? We have introduced the characters 1, 2, 3 and 4, and we removed character 3, whereas in this tree we are not removing any of the characters. How I know? Because there is no bracketed numbers, and that means no characters removed. Let us start from here. Species A has got character 3, this one. Let us take this case, character 3 comes in A, which is found here. Now, A is equivalent, instead of having 3, character 1 came and then character 4 came, and that is what is found in species B. In species B, characters 1 and 4 are found. Character 1 and 4 are found, whereas character 4 came in some of the evolved versions of species A. In some cases, instead of being added the character 4, character 2 was added. So, finally C gets characters 1 and 2 and this is found over here. Since no character reversal was required, in this case this tree might be preferred by others. So, here what has happened, the different steps, characters added 1, 2, 3 and 4. So, total 4 steps were taken, and here if we see total 5 steps were taken. Let us take another example of how the stratigraphic position of the species A, B and C can matter. Here again we are taking the 3 species just like our previous case, but we are taking the data matrix different from the previous one. You can look at this matrix and look at the previous example matrix, they are different. For example, for species A, none of the characters are present, whereas in the previous example in species A, character 3 was present. It is good to have different examples and see how things work. We have to recollect the two definitions: presomorphic, the character or state that occurs in the ancestral morphotype, and apomorphic, which means the derived characters or states. As usual, 0 is the primitive state and 1 is the derived state. So, from this matrix the most parsimonious cladogram has been prepared. This is the most parsimonious cladogram, which shows that species C has got characters 1 and 2 here, species B has got characters 1 and 4, species A has got none of these characters. Now, we are incorporating the stratigraphic position of the species just as our previous case. Here species A, species B and species C do not share a common stratigraphic zone. That way this present problem is similar with this problem, but as I told you, matrix wise the situation is different. Now, the evolutionary tree or the tree has been constructed in this way. A was there, character 1 was added in some of the forms of A, so that what is found as A, we do not see any of these characters, and then after 1 being added up, few cases character 2 got added, so that C has got 1 and 2 here, 1 and 2, and B gets 4 and 1, B gets 1 and 4. Now, we can define a term called stratocladistics. It is a method of phylogenetic inference that uses both morphological data, that means the physical characters based on which we can define the characters, and the stratigraphic data, the fossil occurrence in the geological time. Say this is the situation. In this present example, species B and species A has a common interval also where they co-occur. This is the place of co-occurrence of A and B, and in this way this problem is different from the previous problem and also is different from the previous problem, this one. The data matrix we are going to deal is also different from the previous case. Here we are dealing with 3 characters, whereas in the previous example we have dealt with 4 characters. And if we look at the entries 0 and 1, they are different from the previous problem. So, we understand that this new problem is different from the previous problem. A cladistic cladogram looks like this. A has got none of the characters, all zeros, whereas C has got only character 3 coming from here, and B has got character 2 and 3 together, and which is shown in this way. Now, keeping in mind that the stratigraphic position of the units also to be taken care, while explaining the evolution, the tree can be constructed in different possible ways, such as figure D, figure E and figure F. Here we will be introduced with the concept of stratigraphic date, morphological parsimony date and stratigraphic date or the stratigraphic parsimony date. We will come across one by one. Let us start with figure number D. We are little bit changing the positions of the species. Here you see A, B and C, but we have brought here A, C and B, and that is permitted so long we maintain the zones in which they occur. These solid lines indicate the zones as it is. One can match with this original figure. Now consider that C was actually present here, but due to poor sampling or due to stratigraphic issues or preservation issues, we could not locate them. So, in that case the situation becomes drastically different. Consider A has evolved from here to there without acquiring any characters. Now consider few of the A species got acquired character 3, and then the entry for C is defined, whereas some of the A species acquired both 3 and 2 and evolved in this way 3 and 2, and B's character are explained. In this case we define the stratigraphic parsimony date or the units of stratigraphic parsimony date as this particular region. Stratigraphic parsimony date is due to the missed sampling or due to poor preservation of the taxa. Now we will look at another possibility E. A has evolved in a manner that no characters 1, 2, 3 developed, but some of these A species acquired 2 and 3 and it evolved there. So, in B we get 2 and 3, and in case of C, some of the A species acquired this character 3 and then it continued, where this is our stratigraphic parsimony date region, where there was C, but then that got either not preserved or due to wrong sampling or incorrect identification C was missed. We will now take the possibility F. A has evolved independently and none of the characters 1, 2, 3 developed. Some of the A species acquired 2 and 3 and then it evolved, and this is the explanation for 2 and 3 both present in case of species B. Now at this point of time Tm character 2 got obliterated, so that in C instead of 2 and 3 only we get 3. As you see here in C only we get character 3. Now out of so many possibilities, tree D, this one is preferred by the cladistics, whereas tree F is preferred by the stratocladistics, this one. In case of stratocladistics, the preferred tree is the one where no stratigraphic parsimony date persists, whereas the preferred choice in cladistics is one where no character reversal happens. So, which one we choose? Taking care of stratigraphy, we are going to choose option F. This can be the preferred choice. Here is a self-explanatory situation of different kinds of lineage segments. Species A, B, C, D, E are all plotted with respect to vertical axis of time. Then we can have two possible explanations of their evolution. There are many other possible evolutionary trees. Can students create another possible tree? We are going to see a few definitions about trees. Root is the starting point or base of the tree. Suppose this is a tree presented, then this point can be called as the root. Branching points are the internal nodes or the vertices. So, these are the different branching points. Internodes or internal branches are the segments between the nodes. So, this can be called as a internal branch because this is a segment between the nodes. Terminal taxa placed at the tips. Say this taxon finally persisted on the earth, then this one is called as the terminal taxon. Terminal branches, what are they? Segments leading from the internal nodes to a terminal taxon. So, this particular branch can be called as the terminal branch. Trees can be constructed in three ways. The non-metric trees are those with branches of equal length irrespective of how many characters may be assigned to it. Consider that the length AB, curve line's length AB is equal to that of BC is equal to that of BD, even if here characters 2 and 17 came, here only single character 1 came, and here came the characters 3, 5 and 9. So, although there are different numbers of characters that have come, what are those numbers? Here the number is 2, here the number is 3 and here the number is 1. Nevertheless, the branches are of equal length. Such trees are called the non-metric trees. What is a metric tree? Relative lengths of the branches are drawn to reflect the number of character changes. For a metric tree, the BD length will be maximum, then will be the BA length, curve line length, and then will be the BC length. If the tree is drawn that way, the tree is known as a metric tree. What is an ultrametric tree? Each of the terminal taxa is fixed at the same distance from the root by assuming a constant molecular clock. I avoid this portion, requesting students to draw an ultrametric tree based on this information.